What if I told you that one of the most important lessons you ever learned about data happened way before you even knew what data was? Today, we're going to dig into a powerful idea about how we see the world, and it's all hidden inside a simple childhood game. Seriously, forget spreadsheets and algorithms for a second. Your first real brush with data analysis probably had more to do with toys than code. Let's dive in and see what a simple third-grade math problem can teach us about the very fundamentals of data. All right, so our story kicks off with a classic challenge. You've got a group of animals and birds, and they decide to form two teams. But the first big question is, how do you pick the captains, and make it fair? Well, the rule is just beautifully simple. It has nothing to do with who's strongest or who's fastest. Nope, it all comes down to their names. The captain of one team will have the longest name, and the other, you guessed it, the shortest. And just like that, boom, we've got our winners. The elephant takes the crown for the longest name, and the humble ox wins for the shortest. The game wasn't won by scale at all, was it? It was won by simple counting. And right there, that's the magic trick. We literally just turned names into numbers. Elephant becomes number 8, and ox becomes 2. And that simple act of counting them up and comparing, that's it. That's the whole game. And that right there is our very first piece of data. Okay, but this isn't just about counting letters. We've actually stumbled onto something way, way bigger here. This little game, believe it or not, is a kid's very first lesson in comparing data. So what we were just doing, it actually has a pretty formal name: string length comparison. It's a huge deal in computing and data science, and really, it all just boils down to that simple question we learned on the playground: which word is longer? But, things aren't always that clear-cut. What happens when the data isn't so simple? What if you compare two names and there's no obvious winner for longest or shortest? So check this out. Both Mahesh and Kartik have exactly 6 letters. In our Captain Challenge, that's a tie, plain and simple. And just like that, our game taught us something new. Sometimes the answer is just, they're the same. All right, now this is where things get really, really interesting. What if you could take the exact same group of things and sort them in a way that tells two completely different, but equally true stories? So meet Teji. She's got a stack of picture cards, and she sorts them logically. One pile for things that eat food, and another for things that don't. Seems straightforward enough, right? A nice, clean, logical system. But then, in comes her friend, Jojo. He grabs the very same pile of cards and he sorts them too. But when he's done, his groups look totally different. How is that even possible? What other rule could he have possibly used? And there it is. Jojo used a completely different rule. Can it fly? All of a sudden, the bird is in a totally new group. And here's the key. Both Teji and Jojo are 100% correct. They didn't change the cards, they just changed the question they were asking. And this idea, this logic of sorting, it isn't just for kids' games. It applies to, well, pretty much everything. Let's try it with some stuff you've probably got lying around your house. Okay, so let's ask our first question. Does it need electricity? Based on that one rule, the TV, lamp, and fan all huddle together in one group. Everything else forms another. It's a simple, logical split. But hold on, we can sort those exact same items by what they do, by their function. Now the chair, bed, and pillow are together as furniture and bedding, while the TV, clock, and fan are all grouped as appliances. See that? 2 different stories from the exact same data. The rule you choose is everything. So let's take this little name game of ours and apply it to the wider world. Because it doesn't just work for animals, it works for numbers, and as we're about to see, it even works for the names of real places. You can totally play the name game with numbers too. Take the number 77. Now write it out as a word, 77. If you count the letters, you get 12, which actually makes it one of the longest number names between 1 and 99. It's the same simple idea, just applied in a whole new way. And if you want to see this game on a truly epic scale, well, get a load of this. Venkatana Rasam Haraju Veripata. I know, it's a mouthful, but it's a real place in India and it holds the title for the longest place name in the country. Our simple counting game just got a serious upgrade. And of course, on the complete opposite end of the spectrum, you have the shortest place names. You've got Ib in Odisha and Ode in Gujarat. Just 2 letters. This contrast just powerfully shows the huge range of data you can find just by looking at something as simple as the length of a name. So, after all of this, what have we really learned? What's really in a name? Well, it turns out there's a whole lot of logic and data and structure, all hiding right there in plain sight. Let's just put it all together. That simple game taught us that counting letters is just a form of collecting data. And the big lesson, how we sort that data depends completely on the question we ask. These aren't just rules for a game. This is the absolute foundation of analytical thinking. And we learned it all before we even left the playground. Which, of course, leads us to a final, much bigger question. If all of that logic was hiding inside something as simple as a name, what other powerful ideas are we overlooking every single day? What patterns are sitting right there in front of you, just waiting for the right question to be asked?